Alright guys, this is just breaking the ice for tomorrow, so I'm going to try to make this video as short as can be, okay? First of all, we need to brush up on our simplifying radicals, okay? Hey, you know what? You can use your calculator to work these out, so go ahead and pause the video, try it out. If not, do it by hand. Alright, we're back. So the first one should be 3 root 2, the next one, 2 root 3, and the last one, 4 root 2. I used perfect squares, okay? 9 times 2 is 18, 4 times 3 is 12, 16 times 2 is that 32, square root of 16 is 4, square root of 4 is 2, and square root of 9 is 3, okay? This should just be a blast from the past. Now, on the other hand, I will start putting them in the denominators, okay? And the easiest way to get a radical out of the denominator is to multiply by the radical over itself. We can do this because, well, root 2 divided by root 2 is 1. But in order to get rid of this radical, well, remember when we multiply radicals we get 4? So watch this. Multiplying straight across, we get 1 root 2 over root 2 times root 2 is root 4. And I'm going to come right down here. What's the square root of root 4? 2. We don't need the 1 out front, so root 2 over 2. That's it. Okay? That's all you're doing is multiplying by whatever that denominator is over itself. Okay? Do the same thing, root 3 over root 3, because we're trying to get rid of this radical. Multiply it across, boom. Get 2 root 3 over 3. That 3 came from this. Root 3 times root 3 is root 9. Square root of 9 is 3. If you notice, there's a pattern here. If it's the same base, you just drop the radical sign. Okay? So the last one over here, ooh, be careful with this one. Be careful with this one. Just kidding. Anyway, notice what happened here. We multiply by the radicals, true. But look what happens. This turns into a 6. We got the 4 out front, but we reduced, okay? 4 divided by 2 is 2, and 6 divided by 2 is 3. All right? Keep that in mind. But hey, you know what? You can plug all this in your calculator as you see it, hit enter, and get the answer. Okay? Now, to try this out, go ahead and draw yourself a square. I was going to give you a handout, but you know, this is more fun. You're going to need to draw one diagonal. This is a diagonal. A line that connects the opposite corners. This says if the area of a square is 25 inches squared, label the length of each side. Okay. To find the area, that's length times width. But since it's a square, all the sides are the same, so we're going to say s squared. Well, s squared is going to be 25. What's the square root of 25? 5. So each side here should be 5 inches, of course. What is the perimeter of the square? We'll add them up. 5, 5 is 10. 2 more, 20. 20 inches. Okay, I added 5 plus 5 plus 5 plus 5. What is the length of the diagonal as an exact value? Well, guys, remember, a square have 90 degrees in the corners. And we're going to use a squared plus b squared, Pythagorean theorem. Remember that from middle school? So this one's going to be 5. That one's going to be 5. C is what we're looking for because that's the hypotenuse. Okay? Let me rewrite that. This is going to be C. A. B. We're looking for C. That's hypotenuse. Well, 5 squared is 25 plus 25 equals C squared. 25 plus 25 is 50. C squared. Take the square root. And the square root of 50 is going to be, you know, we're simplifying it. I'm punching in my calculator. And we get 5 root 2. notice anything here? 5, 5, 5, root 2. Keep that in mind. We're going to use that later. For any given side length s, how much bigger is the diagonal than s? Just that root 2. So we're going to say the hypotenuse here is going to be that side length with the root 2. Okay? I'm using a cursive S so you don't mistake it for a 5. That's a cursive S. That's a cursive S. Okay? So we got this chart here. We use Pythagorean theorem. If the leg is 1, see the L's? That means they're the same, so that means these legs are the same. Alright, hypotenuse. Guys, our lesson's being learned right here. We're just tagging on this root 2. It happens all the time with a 45, 45, 90 degree triangle. Okay? Because, hey, this diagonal also bisects these angles, and that's where that 45 comes from. Okay? 45, 45, 90. So, hypotenuse, we just tag on the root 2, skadoosh. 2, root 2, skadoosh. 3, root 3. Keep it simple. Holy moly, I put a 3 there. What is wrong with me? I said keep it simple. What's wrong with it? There you go. And you can figure this out. If you plugged in 3 for these legs, you would still go 3 squared plus 3 squared equals c squared. Again, hypotenuse is the c. 9 plus 9 equals c squared. That's 18 c squared. Take the square root, and you get 3 root 2 when you simplify it. Okay? So, what relationship do you notice between the lengths of the legs and the length of the hypotenuse? We're just tagging on that root 2. It so happens that this relationship is always true. So whenever you're dealing with a 40, oh my gosh. Whenever you're dealing with a 45, 45, 90 triangle, these are the vertices measures, your hypotenuse is always going to be those sides, root 2, or legs, whichever word you want to use. Okay? I say sides for the S because a square, it's always going to typically derive from a square, but, you know, you say tomato, I say potato. Guys, you're going to need to memorize this. So you may want to jot this down on the next blank page. When I mean next blank page, I mean, don't forget, we got to make a unit. And this is going to be units. Oh, let me go find out. All right, I'm back. This is going to be unit. Oh, dagnabbit, I don't forgot. That's what I thought. This is going to be unit 2. Right triangle tree. Put that on the next blank page. This will go on the next page, and you can title it 45, 45, 90 triangles. It's really going to be called special triangles. Special properties of triangles, but you know, we'll get into that. And if you don't want to put this in your book yet, just wait. I'll make sure you do the right thing. Okay? And I say to memorize it because it's an easy pattern. Okay? L root 2, nothing to it. But, you know, we really don't need to memorize it if we can memorize the trig function. And I'll get into that later. Okay? So this works because all 45, 45, 90 triangles are similar triangles. Start getting used to these terminologies. We're going to be using them. You remember what that means? What's the characteristic of the sides of a similar triangle? Guys, we're going to say similar triangles. Whenever we use the word similar, we're going to say same shape, different sides. Okay? Similar Same shape, different size. All I want you to keep in mind. In similar triangles, the sides are going to have same ratios, but we'll get into that later. Okay? And again, this is re-emphasizing what I was talking about with the ratios. The formula still holds true, even if you scaled it up by 3. See that? It had a scale factor of 3. It means it got larger. Alright, so pause the video. Try these out. All you're doing is looking for the hypotenuse of leg, just the missing information. And after this, we're going to call it quits, because what time is it? Yeah, we're going to call this so quits. So, leg for 45, 45, 90, the leg should be the same, so 3. Hypotenuse, you just tag on the root 2, okay? Keeping it simple. Hypotenuse says 7 root 2, we're going to drop the root 2 and just put 7. Boom. The leg is root 2, well that means this has to be root 2. Hypotenuse, well, our formula says L root 2. They're telling us the leg is root 2, so I'm going to plug that in. Root 2 times root 2 is root 4. Square root of 4 is 2. Boom. Hypotenuse is 4. Okay. Leg, root 2. We got to divide by root 2, and this is where simplifying by the denominator comes in. Guys, I'm plugging this in my calculator because, hey, I'm not saying you can't use it. So 4 root 2, and I get 2 root 2. I think that was one of our examples. Boom, all done. Got the right answers. We're going to do Farmer Jake, use a special instrument. Guys, we'll tackle this tomorrow because this is going to start applying to our project we're going to do for the kite. Go ahead and try this out if you want to, but I want to save this for tomorrow, and this will be our warm-up. Okay? Y'all have a good night.